This video is about tilting laminas. Here are a couple of diagrams that explain how this works. If we've got a lamina here which is suspended from a fixed point, then the centre of mass lies vertically below the point of suspension. And the same if it's pivoted about a point in the middle of the lamina, or at any point of the lamina. The centre of gravity lies directly below, vertically below, the point around which it is pivoted. So here's an example. We've got a lamina here. It's an L-shaped lamina. And the question is to find the angle that the line AB makes with the vertical if this shape is freely suspended from A. So the first step is to find where the centre of mass is. Now to do this we need to split this L shape into two sections. I'm going to split it along here. So the centre of mass of this section here is clearly going to be at that point there, 2 along there and 1 up there. And the centre of mass of this rectangle is going to be here. That's 1 along, and it's going to be 4 up. So if we take A as the origin, then the centre of mass of this rectangle here is going to be at 2, 1, and this mass is going to be proportional to 8. And then in the second rectangle, the centre of mass is going to be 1 along and 2 plus 2, 4 up. And again, the mass is going to be proportional to the area. 4 times 2 is 8. And that's going to be equal to the total mass, 16 x bar y bar, where x bar y bar is the coordinates of the centre of mass. So x bar is going to be 16 plus 8, 24 divided by 16, that's 1.5, and y bar is going to be 8 plus 32, that's 40, 40 divided by 16 is 2.5. So the centre of mass is going to be 1.5 along and 2.5 up. So it's not quite 2 along, 1.5 along, 2.5 up, it's going to be about there. That seems about right. Now the mistake would be to try and draw this shape with the downward vertical showing as a vertical. So we've got the downward vertical there, we've got AB here, we've got AF up there. To try and draw this like this, it becomes very messy. So don't do this. Really, just don't do this. It's very easy on this diagram that we're showing here to show the downward vertical, because we know that the centre of mass is at 1.5, 2.5, so we know that there's the line to the centre of mass, and what we're after is the angle that AB makes with the vertical. So what we're after is this angle here, and we know the coordinates here. That's 1.5 along, that's 2.5 up. So now it's very simple. Tan theta is simply 2.5 over 1.5. So theta works out to be 59.0 to 3 sig figs. The one thing that I think you ought to do is to make it clear where the downward vertical is. So you need to, on your diagram, show this downward vertical. I'm having to squash it in a little bit. But show the downward vertical so that it's absolutely clear what you're doing, so the examiner can see that you know how to answer this question. But once you've written in downward vertical like that, then you're in business. So that worked quite well because we knew that the lamina was suspended from A. So we drew a line from A to the centre of mass. If it was suspended from B, you draw a line from B to the centre of mass. If it was suspended from E, you draw a line from E to the centre of mass, and so on. But as always with mechanics with a good diagram, these questions suddenly become very straightforward.